In this unit, we're going to be talking about transformations. And what transformations are, look at the top, they're an important concept in geometry. Basically what they do is they just take an original shape, image, or figure and creates a new figure through slides, which we call translations, flips, which we will get to in the next lesson, which we call reflections, turns, which we call rotations, and enlargements or reductions, so kind of making a figure bigger or smaller, which we call dilations. And we'll get all to that later on in this unit. But the one we're going to talk about right now is translations. And a translation is just a type of transformation. It takes a geometric figure, changes its position, but does not change the shape or size. So it's just taking the image on one part of your coordinate plane and then moving it to another part. The original figure, we call that the pre-image, and the figure after you do the transformation, we call that the image. Okay, I'll write that a little neater. We call that the image. The diagram to the right kind of shows a translation. This guy right here, that's the pre-image. And then they moved this figure 5 units to the left. So they took this point B right here and went 1, 2, 3, 4, 5 units to the left and then moved it up 2 units. Same thing with C. They started with C and they moved it 1, 2, 3, 4, 5, up 2, 1, 2. Same thing with A. 1, 2, 3, 4, 5. Moved it up 2. After they moved that figure 5 units to the left and 2 units to the and 2 units up, they got the image. And this guy right here is the pre-image. Okay? Moving to the left, just kind of like if you think about how when you do rise over run, if you move to the left, it's a negative x direction. Moving up is a positive y direction. So how we would say this is it'd be -5 and then +2. You take all the x values and subtract 5 from them. You take all the y values and you add 2 to them. You also might see it like this. That's another way of writing kind of this rule is the capital T stands for translation, and you're saying subtract 5 from your x values, add 2 to your y values to that figure triangle ABC. If a pre-image and an image are congruent, so the size and shape didn't change, it just shifted on the graph, we call this an that right? Yep. An isometry, or we might say it's a rigid motion. That's kind of how I like to call it. You'll hear me call that a lot. Is it a rigid motion? Or, and we'll get to this later, a congruence. Transformation. Okay. Sorry for my sloppy handwriting. So in the next example, we're going to graph the pre-image with the points that they gave us. So let's do that first, and then we're going to follow the translation that they gave us. Okay, so we're going to plot 5, 1. Here is 5, -2. 2, -2. And 2, 1. Make sure you label your points. 2, 1 was X, W. The next point was X, Y, and then Z. And we need to, here's the image right here, this quadrilateral, and we're going to follow all of this transformation. We're going to translate the image 5 units to the left and then 2 units up. Okay, so you're going to take the vertices of each point and move it to 5 units to the left. You just count 1, 2, 3, 4, 5, and then 1, 2. That is our new W. And when we write a new point of the image, we put a little tick mark to show that that is the new point. And then we take X, same thing, move it 1, 2, 3, 4, 5 to the left, up, 1, 2. There's our new X value, our new X point, and X with a tick mark. And then same thing with Z, move it 1, 2, 3, 4, 5, up, 1, 2. Z with a tick mark, and then Y, 1, 2, 3, 4, 5, 1, 2. Left 5, up 2. So we have Y with a new tick mark. Make sure you connect the points. And then there's our image. We took the original pre-image, moved it left 5, and up 2. We're going to do the same thing with number 2. So we're going to graph those same points and then follow the translation that they gave us. So we had 2, 1, 5, 1, 5, -2, 2, -2. And it's W, X, Z. Okay, there we go. W, X, Z, Y. And we want to follow this rule. And what it's saying is, because there's a +1 where the X value normally goes, that means we're moving all our points to the right 1. Then the next number is we are moving, because it's the second one, that's the Y value, we're moving them all down 3. So if we start with W, we move it to the right 1, and then down 3. 1, 2, 3. So there's our new W. Same thing with X, right 1, down 1, 2, 3. Same thing with Y, right 1, down 1, 2, 3. And then same thing with Z, right 1, down 1, 2, 3. And there is our image. Okay, make sure you label. This is W, X, Y, and Z. There we go. And sometimes that will happen. Sometimes the image will kind of overlap with the pre-image, just based off the rule that you were given. So number 3, it's a little different. We have to see what translation we did to go from this original, from our pre-image, we have to see what we did with A, B, C, D to translate it to the A, B, C, D down here. So what I like to do, so what you're going to do is you're going to pick any point. I'm going to pick point A. And then count, start at this point A, and see which direction you went to go from that new point A. So, and it doesn't matter how you make your rule. Let's do it this way. So we're going to say, because we're doing a translation, we're going to say a capital T. Count how far you went to be in line with the new A. So we went 1, 2, 3, 4, 5, 6, 7, 8. And we look at the direction you went. We went to the left 8, so it's going to be negative. Okay? So then see how far we counted down. We went 1, 2, 3, 4, 5, 6, 7. And again, we went down. So it will be negative 7. Then make sure you include your shape. Make sure you include the shape. And the original shape was A, B, C, D. There we go. There's the rule. Is there symmetry or is it a rigid motion? Yes, because we just took the shape, we moved it left 8 and down 7. We didn't change the shape of it. And then true or false is any translation of rigid motion. The answer is true. Okay. Any translation is in rigid motion because again, you're not changing the size or shape when you do a translation. You're literally just shifting it around on a graph. So it's the same figure, it's just in a different location. Okay. And there you go.